Let's take a base number. This can be any number that is not equal to 0. We'll call it b. Now let's raise b to a certain power. We'll call the power p. We'll call the product n for number. Now I'm sure this expression looks pretty familiar. It's an exponential function. It's just a value with an exponent giving us a product that is the base multiplied by itself p amount of times. So let's look at an example. 3 to the power of 3 is 27. That is 3 multiplied by itself 3 times. 1, 2, 3. 3 multiplied by itself 1, 2, 3 times gives us 27. Now the exponent p is referred to as a logarithm of the product n and can be rewritten as log base b of the number n will give us the power. This is the general form of a logarithm, and it's a very useful tool in mathematics. Let me show you why. Using our example, let's say we were only given the number 27, and we needed to find the logarithm p in base 3. In other words, 3 to the power of what will give us 27. Well, 3 is the base, so log base 3 of the number n of 27 will give us that power. Using our calculator, log base 3 of 27 will give us 3. Wow, look at that. 3 to the power of 3 gives us 27. Now this example is rather simple. For something like this, some quick mental math will get you along the way. Let's look at a different example. So let's look at another problem to properly show the usefulness of logarithms. 5 raised to what power gives us 1,953,125. So the base number will be 5. Log base 5 of the number, that'll equal p. Using our calculator, log base 5, 1,953,125, 9. So 5 to the power of 9 gives us 1,953,125. P equals 9. Look at that. However, this example also could have been done without logarithms, as the power was a whole number. You could have multiplied 5 by 5 by 5 and counted how many times you multiplied 5 to get you that number. But most of the time, logarithms aren't whole numbers, and you can't use that method. Let's do log base 5 again. We'll do 5 raised to what power gives us 187,359.12. Okay. You can see that the power will not be a whole number. You cannot multiply 5 by itself that many times to get that. Mainly because you can see a decimal. So, let's put it in the logarithmic form. Log base 5 of the number will give us p. Using this, log base 5 of 187,359.12. There it is. P equals 7.5435. 5 to the power of 7.5435 gives you that number. You may be wondering, where are logarithms used in the real world? Well, among many applications, a good example is in chemistry, the pH scale. The pH scale is a measure of how acidic or basic a solution is. Now, for those of you who don't know, the acidity of a solution depends on the amount of hydrogen ions in that solution. Now, hydrogen ions is represented by this symbol right here, with H plus representing hydrogen and the square brackets representing concentration, which is measured in moles per liter. Anyways, pH actually stands for power of hydrogen, and a solution can have a pH level from 1 to 14, with 7 being neutral, a pH of 1 to 7 being acidic, and a pH ranging from 7 to 14 being basic. Anyways, the pH scale is a logarithmic scale, meaning the pH value of a solution is a logarithm and is equal to negative log in base 10 of the concentration of hydrogen ions. So if we had a solution and we knew that there was a 2.81 times 10 to the negative 10 hydrogen ion concentration, we'll find that the pH of that solution is negative log base 10 of 2.81 times 10 to the negative 10, which equals negative log 2.81 times 10 to the negative 10. 9.553. Now notice here that when I entered in the logarithm, I did not use this button as I previously did. This gives you the option to enter in any base number you'd like. Instead, I use this button, which just says log. Now when it just says log, which is the only option to use logarithms on most simple calculators, when it doesn't give you the option for the base, that means that it's in base 10. And the reason for that is because base 10 is the most commonly used logarithm. Just something to keep in mind when solving logarithms.